Sister and brother surfers of the binary ocean, what's up? We got a lot to do in this video to set up for our flow control in our fourth, so let's jump in. First thing I want to do is just fix just a quick little error here. Simple fix. So I noticed this bug just as I was doing some working on the code for this flow control that we got coming. And when we have a word, if we run a word that we've defined ourselves, and then basically anything after that word just gets ignored by the compiler. So this should, it should put 40 on the stack and then put 10 on the stack and then show the stack. And if we run it, all we get is 40 on the stack. So it's ignoring everything after that. It's a pretty simple fix, but we do want it to see all that stuff. So let's hop into our code here. We want to scroll down in our process input function where we are running our run word stuff here. And I'm going to change these returns a little bit around here. So we actually can, and we will, return 0 from this one. We won't return anything from 1, and we'll return 2 from the error ones, and then from this other set of run word return codes, a run word function, else if else, we're going to take away the return 1 from that 1 as well. That's what that's going to do. Is it stops so that when that 1 is returned, it stops this process input function from running. And we don't want that because we still have things in our input array that need to be processed sometimes. Like in this case right here, there's still a 10 in that show that needed to be processed. So we don't want to return anything. And by not returning anything, we're not ending that process input function. We're letting it continue and finish. And when it is finished, it will, at the very end here, it returns a 1. So all good. Should work now. Let's save that. Let's run it and just make sure. There we go. So we got our 40 on the stack from this, and then we got our 10 on the stack, and then we showed our stack. So all good now. Now, for the big stuff, this is we are going to add a bunch of functions here that are going to get us ready for our flow control, like if then, if else, while, for loops, that kind of thing. You need to be able to check conditions, right? You need to be able to check, are two values equal, or are two values not equal, or is this value greater than that value, that kind of thing. So we're just going to add functions to do that. We'll go to the very end of might as well just add it to the end. We can always rearrange this stuff later if we want. But so the first one we're going to do is equal. And it's pretty simple. We're just going to let's go up to let's just copy one of these. We'll copy from the subtract one is fine, whichever one. We just want these variables, top word and second word. We're going to need that. And to check if something's equal, well, now we're going to need an if. So we need if top word is equal to second word. And here's how fourth will handle that. Fourth, to tell if something, if two things are equal, then the value will be true. So it just simply puts a -1 onto the integer stack. And that means true with fourth. Else, it puts a 0. That means false. And so we're going to be doing this quite a few times. Let's just go through our functions first, and then we'll put our function calls in our dictionary up here so that they can be used. So let's do that. Let's see. We got equal. Okay. Let's do not equal. So we'll just copy equal and make some adjustments here. That's probably the quickest way to do that. So not equal. And we still want the top two values, and then we want to check if they're not equal instead of if they're equal. normally what I would do if I was just as I was doing this the first time through, I actually, made one function, put it up in the call, and then ran my code to test it. Now that I know all these work, we're just gonna, just to make things not take forever in this video, we'll just do all the functions at once and then test everything at once at the end. So the next one will be and. So that's if we want to, so if A and B are true, then we want true, right, on the stack. But if A is false and B is true, then it would be false. That's some general programming logic there. So nothing too crazy. Let's just copy this again from what's in our not equal. And then we're gonna change our if logic here a little bit. So it's gonna be if top word equals second word. Actually, yeah, that's it. It's going to be the same as equals basically, because with fourth, since it's stack based, it's gonna, let's say we want to see if 20 equals 20 and 30 equals 20. Here's how fourth works. That's how we would put it. We would enter it like that. And then that would boil down to 20 would go on the stack, another 20 would go on the stack. It would check to see if those two values are equal. If they are, then it'll put a negative, and they are, so it'll put a -1 on the stack. Okay, and then it's gonna put a 30 on the stack, and then a 20 on the stack. It's gonna check if those two values are equal, and they are not, so it'll change that to a 0. And then the and here will just check if both of those are true. If both of them are true, then it'll put true, which is -1. If one of them's false or they're both false, it'll put 0. I hope I'm saying that and logic right, but anyway, that's how it'll work out. And then we got func or. This part was really fun for me to kind of work out because just seeing stuff like that, like how equal and are the same thing, because it's stack based, and just thinking about the stack, it's fun to think in a stack based way, I guess. So let's see, this one we want top word equals -1 or second word equals -1. So let's go through how that logic works. So it's like 2020 equals 30, 20 equals or. Okay, so it's gonna get 20 on the stack, 20 on the stack. If they are equal, it puts -1 on the stack, puts 30 on the stack, puts 20 on the stack. If those two are equal, they're not equal, so it'll put 0 on the stack. If either one of those is true, which this one is, then the end value is true. So if that's -1 or that's -1, then -1, else 0. So that's our or, and then we got few more to go here, because I do want to add some other words that are just kind of general, like common fourth words that'll be useful. Greater than. Let's copy this again. It's all just basic logic here. So we've got our top word, our second word. Okay, this one's if second word is greater than top word, and then less than, we'll just copy this whole function here. Less than this one, second word is less than top word. All right, so that's good for our logic. Now, what if we want like greater than or equal to? So if we wanted greater than or equal to, we couldn't put that into a word unless we have some other helper words. Like we could spell out greater than or equal to. It would be like if 20 is greater than 10 or 20 is equal to 10, and then we put an or. So that would be greater than or equal to. But what if we want a word to capture that? It would be like greater than or equal to, and then say we have, just 20 and 10 on the stack. How do we see that it's greater than or equal to? I'll show you how we do that. We got to add a couple more words, and then we'll use one of the words to do that, or maybe a couple of the words to create that. We'll actually create that in Forth. I'll show you that. It's kind of fun. This one, we just need the top word. That top word, and then we just want to int stack dot append top word, and just do that twice. That's going to duplicate whatever's on the stack, whatever the top value of the stack is. Okay, and then we want swap, and that just takes the top two values on the stack and swaps them. So if we have 10 and 20, it changes them to 20 and 10. So let's get our top word and our second word variables. And we do int stack append top word, and then int stack append second word. So now the second word is on top and the top word is second. And then the next one will be function toDup. And in Forth, that's actually 2DUP, like that, but we can't start a function with a number in Swift, so we're just spelling it out. toDup. And just copy that. Oh, why did I copy that one? Yeah, toDup duplicates the top two values on the stack. So we have top word, second word, and then we want to append the second word, and then append the top word, and then do that once again. All very simple, kind of like simple arithmetic type stuff. And then ROT is rotate. That rotates the top three values on the stack. So that's kind of interesting. And we'll actually need this one to make our greater than or equal word. So we're going to need to get the third word as well here. This shouldn't be words anyway. Those are values, huh? I just realized that. Oh well, get the idea. Refactor that someday. Okay. And then, so int stack dot append second word becomes the third word. The top word becomes the middle word. And the third word goes from the bottom to the top. So it just rotates it. Let me think if is that counterclock? Would that be like a counterclockwise or a clockwise? So say we have 1, 2, and 3 on the stack. Then the lowest one on the stack becomes the top one. And then the what was on the top just gets pushed back. It would be a counterclockwise rotation, I guess, right? 2. Is that right? Let's see. The second word, yeah, it would be on the bottom. Yep. So there was this thing we used to do when I would run cross country and track, where it was like a drill where, the person at the back would have to run all the way up to the front every time the coach blew the whistle. So whenever you move that one, that's what you get. So it just keeps taking that each time you call rotate. And then let's just make our if-else function. We're not going to do anything with this part. We're not going to get this far yet. So we have all these functions. Let's go back up to our process, input our dictionary area, and then right above our colon here, where we have like add, subtract, multiply, divide, pop. Those are our kind of common Forth words. So we'll just add the rest of these with those. And make ourselves a little template here. We just copy this. Okay. And then we're going to call, so we got equal. And then we've got not equal. we have and, we have or, greater than, less than, dupe, swap, to dupe, I don't know why that swap is gray. That's weird. What did I do? I'm not sure. Okay, we'll just leave it for now. To dupe, and then rotate. And I believe that's all of them. So let's put what forth we'll see. So equal and forth not equal is that. Less than, greater than. And will just be and, or is or. Greater than is that. Less than is that. Dupe is DUP. Swap is SWAP. To dupe is the number 2 and then DUP. And rotate or rot is ROT. I think that's pretty much good for this video. Let's just run it. And so just as a test, let's make the greater than or equal to. Let's say we have 10 and 20. Let's see what we get here. 0. So 10 is not greater than 20, right? If we put 20, 10 greater than, we get -1. 20 is greater than 10. Let's say we want to do a greater than or equal to word that we want to define. It's going to be greater than or equal to is the name of it. And the first thing we want to do, so we're going to have to duplicate the top 2 values on the stack. Let's say we have 20 and 10. So then we would have, so here's our stack, 20 and 10. So we do the dupe, and that gives us 20, 10, 20, 10. That's the to dupe, I mean. The top 2 values on the stack. Then we want greater than. So what that's going to do is it's going to take the top 2 values here and return -1 if the second value is greater than, or it's going to return a 0 if the second value, so this value is not greater than. So we're going to get -1 for this one because 20 is greater than 10. And then, so now we've got, so our stack is now 20, 10, and -1. Then we're going to do a rotate. So that's going to put, our stack is going to look like 10, -1, 20. Then we'll do another rotate. So then we've got -1, 20, 10. So now our the second 20 and 10 are on the top, so we can do an operation on them. And the operation will be the equals, because, right, greater than or equal, and we're just checking the same 2 values twice. Is it greater than? Is it equal? And this one is gonna, so then we're gonna have, they're not equal, so it's gonna be -1 at the bottom because of the greater than, and then it's gonna be 0 because false on the equal. And then or, and that's gonna compare these 2 values, and if either of them is equal to -1, then we get -1. So it is 20 is greater than or equal to, because it's greater than 10. So let's make our word and just test it out here. Rotate equals or. And then, so let's do 2010, greater than or equal to, show. Okay, and we already had 0 and -1 on the stack. So we got a -1, and we got that because 20 is greater than 10. Let's try like 2010 greater than or equal to. Wait, that's not right. Oh, I did 10, 20, greater than or equal to. There we go, got a 0, that's good. Good, so that's it for this video. In the next video, we'll do if else, I think, and see how far we can get with that. So thanks for watching. Peace out.